that void. You need to put something in that task 1.
So since there's nothing in that task 1, if you just didn't call pthread join and main is just looping forever, does that other thread still exist? I mean, after it returns from task 1 or whatever?
Okay, just hold on a sec. Let me capture the program first. Okay, go ahead.
Since there's nothing in task 1, if you never called pthread join in main, and main's looping forever, does the second thread still exist?
Nope, it
just
exits
dies
when it returns.
So if you call pthread join at that point,
it will remember. It will still be able to join it.
okay, it'll just
So if a
return
child,
immediately?
exactly, it will just return immediately. A child thread that another thread you're joining with, the child thread can die first, can basically be cancelled first, and then the main thread will still be able to join to it. It maintains which thread has terminated, so it won't get rid of the data structure of a terminated thread until the join operation has occurred. So let's see. I think the compiler will probably complain because I don't have a return 0 here, so I'm just going to stash a return 0. And with gcc-g-p thread -o test1 test1.c. I'm missing. Oh, okay.
Asterisk.
Yep. This one has to return a void pointer too, which means I probably just have to say return null because there's nothing to return. Parameter name omitted. Yes.
Now it's
There we
like,
go.
oh,
You need to compile it with -pedantic and -w error.
The program doesn't do anything. As expected, it really should not do anything.
Put a printf in there. I said put a printf in there.
Yeah, but that doesn't really show you, anything about the two threads being executing in parallel. We can.
put printf in both.
Put a couple of
Child
loops
thread
and have
and
them print
main.
at the same time.
Have one print from 0 to 100 and one print from 100 to 0, each with a 1 second sleep.
I want to see what this is going to do.
That's not
One
going to print
prints-
anything until it flushes.
What?
That's not going to print anything until it flushes.
Oh, there'll be enough stuff to make it flush. Forever, almost guarantees, it will fill up the buffer at some point.
So when the main thread returns, all its child threads die also?
I do not know. Have to look that up.
Like if you just take out the printf inside of main,
I think it does.
then all the child threads will just die too.
I have to read the fine manual to find that one out. Now, this is kind of interesting. It prints a whole bunch of eggs, and then it prints it. So basically, the X and Y's are not interleaved because I think the buffers are flushed at different times. So one will basically fill up the buffer, and then I don't know. They're interleaved in different ways.
What if you throw in a fsync after them?
I think it won't change the behavior because I think okay, this is just, just look at the output. I think these two threads are sharing the same processor. In other words, they're not really executing in parallel, and therefore there's no, interleaving of XY, XY. Each thread gets enough time to print enough X's or enough Y's to fill up, like at least, this portion of the screen.
You need a few sleeps in there. You need a few sleeps in there if you want it to properly interleave.
Yes, if you wanted, you can put a sleep 1 and it will interleave X, Y, X, Y, like that. Or more likely, it's going to be XY, 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 like that.
YX.
Huh?
YX.
Yeah, YX.
So,
Okay.
so if you remove that print though from the main,
Mm-hmm.
does it just, the program just exit, or does it wait for the child to finish?
Okay, so remove this one here.
Yeah, does it? now
It will
just-
wait for the child to finish,
Oh,
which
well.
but the child does
No,
not
I mean,
finish ever.
And if you don't have that p-thread join, I mean, also.
Wait, so get rid of this. Never mind. Habit from Pearl.
Then it's just gonna, does the child thread will die too?
I believe so. Let's see.
Let's find out.
Of course, this is not the best way to find out exactly what the program is going to do because this is just empirical. But basically, this proves that if you don't join, then the child thread will also go
Just
away.
I mean,
Now, to be really sure, we really should be doing this, just to make sure that test 1 does not exist anymore. So test 1 as a process is now gone. Yep.
Huh. Can we throw a sleep in the main one and see what happens if it really does die after the sleep runs out, or if it just never runs?
Okay, sure. Do that. So I want to throw a sleep in here,
Uh-huh.
right? 1 second.
Sure.
So I think in this case it will spill out, it will basically, okay, the child thread has 1 second to execute. When, okay, I think I know what is going to go on, what's going to happen. Oh, it does
I
not.
forgot to compile.
Oh, yeah. That's,
Beauty of a make file.
Yep,
just
1
simply
second.
Test.
yep. Okay, I think what's happening is when main returns, it returns not to the operating system directly. It actually returns to the cleanup code associated with pthreads, and that cleanup code at that point will look at what kind of child processes are still running. If there are any child processes still running, all those will be terminated before the entire process is terminated.
So it doesn't like leave the zombie thread sitting around?
Nope, there won't be any zombies because the cleanup code is actually, in other words, if you look at this picture here, there's some initialization code that we don't see before main gets control,
Sure.
but at the same time there's some cleanup code after main returns that we also do not see. Yep.
Except that if a thread is blocking, it will stay as a zombie process. And
But it's not really zombie at that point anyway. I mean, zombie is defined as something that cannot be killed. That thread can be killed, the process can be killed.
No, what I'm saying is that if it's blocking on certain types of I/O, it will stay even after the process terminates. Because I've watched it happen on my systems before. And it'll actually leave, I don't know if it's, the master thread, but I believe it's just the child thread. So you can terminate, the master thread that's associated with it, but whatever actual thread is still blocking will stay there as a zombie process.
Okay, so you're saying that if I put in, say, scanf in the child process, in this case, then the child thread will become a zombie.
If it was, for example, blocking on a file that it had open off of an NFS partition that has since gone down, so
Mhm.
that it can't actually terminate the thing because it's still
Right.
got pending I/O, then it
Mhm.
will hang as a zombie process. That's just the best example I have, but I mean I've seen it.
Okay, go
There are
ahead.
mount options for NFS that'll prevent that from
Yeah.
happening.
But I'm just saying that's an example of how you can end up with a zombie process like that.
But it won't happen with standard input-output though. Because standard input-output is what they call a cancelable system call, and any system is any